sent debris flying in all directions. Around 1,000 pieces larger than 3 inches and thousands of smaller fragments were ejected into space, posing a threat to all the devices in low Earth orbit. This collision proves that an out-of-control object in low orbit is a danger to all working satellites. Another event worthy of Star Wars took place when China decided to deliberately destroy a weather satellite that was no longer in use, using a ballistic missile armed with an infrared seeker and a warhead. It was an arrogant show of strength by Chinese authorities, with no concern for the consequences.
Okay, I'm going to stop it there. Beyond this size, if we go slightly further, we encountered the first natural body out in space, and that was the moon. You just saw Earthrise there over the moon. The moon, of course, has been visited by humans between 1969 and 1973, and humans have not been back since. The US is hoping to send humans back in the next few years, pending budget cuts at the moment, because it's politically a bit unstable at this time, but we'll see what happens. The moon, again, this is small satellites, but 1/6 the size of the Earth. This animation is made of pictures taken with the Hubble Space Telescope. They put together. You can see how exquisite the optics of the Hubble Space Telescope are and how much detail we can actually see. It's a lifeless body, hardly any atmosphere. There's a little bit of an atmosphere, hardly any. But the moon has been a lifesaver for the Earth ever since the early solar system, because the moon acts as a vacuum cleaner, in essence. When debris comes from outer space, it often encounters the moon first, so a lot of impact craters on the moon show that a lot of debris from outer space was caught by the moon rather than traveling onwards to the Earth. So that's a good thing for us. If we move on, step 10 now, 10 gigameters, we see there, the previous picture, that was the Earth, the moon around it. Now we have part of the orbit. It says 4 days in July. Right? The Earth takes 365 days to go around the Sun. So at this size, that's about 4 days of travel. The Sun itself would be, so that was at the bottom here, the diameter of the Sun is about 1.5 times the size of that central square. So the Sun is quite big compared to the Earth. Step number 11. 10 to the power 11 meters. Now we get to see orbits of the nearest planets. The nearest planets are Venus on the inside and Mars on the outside. And that's about 6 weeks. So here we have a picture taken with the Hubble Space Telescope of Venus. And you can see there's not much visible, because Venus is a planet that has a massive cloud layer around it, and you can't actually look through it with visual light. You can do it with radar. This is what the surface looks like if you use radar to look at the surface. So there's a lot of craters as well, but not as many, because if there is an atmosphere, a lot of the stuff that falls into the atmosphere will burn up, and so it won't reach the surface. This is what it looks like when you land, and this is one of the few pictures we have of the surface of Venus, because Venus has an atmosphere that's very thick, that's very acidic as well, so any instrument you might send down there stops working after about 60 minutes. The Russians did. This is a Russian photo from the 1960s, I believe, and that's kind of what it looked like on the surface. That's probably the best picture we still have of Venus from close up. So Venus is often referred to as equivalent to what happens if you have a runaway greenhouse effect. So that's one thing we have to be careful about, of course, in terms of climate change. On the other side of the Earth, the nearest planet is Mars. Mars is a more benign planet. It does have an atmosphere that's about 10% of that of the Earth. It's the red planet, lots of rocks, not much of interest really there. I mean, it's an interesting planet to study, but it's dead as far as we know. But who knows?
it left 20 degrees. Beautiful planet. Kind of boring though. Photo quality on any paper. Photo Rec 2. Only from HP.
I thought I'd put that in because, who knows? Maybe we are all fooled. Beyond Mars, beyond the orbit of Mars, there's a big gap between Mars and the next planet, which is Jupiter. And in that big gap, we find a lot of debris that looks like this. And these are called asteroids. Most likely the remains of a planet that was pulverized somehow in the early solar system. We've actually sent some spacecraft there. The Japanese have sent a spacecraft to one of these asteroids, which came back a couple of years ago. It was the Hayabusa spacecraft. I went to the headquarters of the Japanese Space Agency about a year ago in my role as the director of the International Space Science Institute, Beijing, and they were very proud of their sample return mission. It was amazing, amazing science as well. Anyway, going out to the next step, we're now at step number 12 of 25. We are now at 1 terameter on the side. What we see now is all of the inner planets in our solar system. We have the Sun in the middle, then we have Mercury, Venus, the Earth, and Mars, and now we get to see the orbit of Jupiter. And you see there's a big gap, and that's where those asteroids are found. Mercury is a very small planet, goes around the Sun quite quickly, has no atmosphere, and has a lot of craters, so it has had quite a lively past, I would say. Jupiter, on the other hand, is the largest planet in our solar system. It's sometimes referred to as a failed star. It's about a significant fraction of the size and mass of our Sun. It's famous, of course, for its big red spot. That is a storm that's been going on for centuries, and it's about 300 times the size of the Earth. So that's big. Cloud layers. This Jupiter is the first of the gas planets in the outer solar system, which probably have a tiny rocky core with a huge layer of gas clouds around it. So all that stratification here is clouds going around the planet. And here are some of its moons visible as well. Moons that were first seen by Galileo in 1609. The Galilean moons, as they're called now. Beyond Jupiter, we have another large planet that we probably all know very well. It's moving, by the way. This is Saturn. Pictures observed with the Hubble Space Telescope, with beautiful rings around it. Probably the remains of some moons that were pulverized. And the gap between the rings is the Cassini division, is kept free by a moon that's going around at the same in the same plane as the rings. Here's another movie of Hubble Space Telescope pictures, and you can see some of the moons traveling alongside the planet. Beautiful planet. Like Jupiter, rocky core, massive gas layer around it. Those rings, by the way, are not solid. It's very likely that the rings look like this. This is an artist's impression, this is not real, but we believe that the rings are made up of small pieces of rock. And part of those, the gaps there's a couple of gaps in there, they're kept clean by a moon that's going around, that's in essence acting like a vacuum cleaner as well. Yes?
Given the similarities between Jupiter and Saturn in terms of their composition and that kind of thing, what's the differentiator that makes Jupiter a failed star versus Saturn?
Mass and size. Saturn is a lot smaller and a lot less massive.
Yep.
You need to have a minimum mass in order to ignite hydrogen in the core, and Jupiter is close to that, but not close enough.
Okay.
And Saturn is a lot less massive. Yeah. Beyond Jupiter, we have Uranus with its moons. There's a lot of moons, and Uranus itself doesn't look very special. It's clouds, and that's it really. This is what it looks like with the Hubble Space Telescope. There's a bit of structure here. These are the similar storms as that big red spot on Jupiter. And beyond Neptune, it becomes really hard with the Hubble Space Telescope to see what's happening, because these are the best pictures we have with the Hubble of Neptune, the outermost planet in our solar system. And you can see it's quite fuzzy. Again, Neptune is like Jupiter, Saturn, and Uranus, a gas giant. Now this is all as the way we see it we could see it with our eyes, visible light. The James Webb Space Telescope has also pointed its camera at these planets, and they look very different. The James Webb looks at infrared heat radiation. Jupiter, Saturn, Uranus, and Neptune. And all of them, by the way, have rings, but the rings of Saturn are best known and largest. All right, where are we now?